So welcome back for another week of CN seminar. Today, I am pleased to introduce our speaker, Dr. Laura Outhwaite. So Laura is a Principal Research Fellow at UCL Center for Education Policy and Equalizing Opportunities, otherwise known as CPO. And she is currently an ESRC Policy Fellow at Ofsted. Laura's research is focused on understanding and addressing inequalities in the early years, including in the home learning environment and formal early education settings for disadvantaged children, including those with special educational needs. Today, Laura is going to talk to us about measuring mathematical abilities in early childhood. Specifically, she will be presenting her systematic review on the psychometric properties of early maths assessment and screeners. So without further ado, Laura, the floor is yours.
Thank you, Stella. That's all right. Thanks, Stella, and thank you to everybody for having me. So as Stella very kindly introduced, I'm going to be talking about a systematic review that we have recently completed, which attempts to synthesize the range of different measurement tools for measuring children's mathematical development in early childhood. So why should we be interested in early mathematical development? So there's a large body of research, for example, that shows that early mathematical skills go on, how well children do in their maths in their early childhood predicts their later attainment, as well as a range of other outcomes, such as employment. But yet, despite the importance of early mathematical skills, statistics from UNESCO show that around 55% of children worldwide don't have the math skills that they need to succeed in their everyday lives. And there are also statistics that show between 5 to 14% of children experience or are at risk of mathematical learning difficulties, which is a specific learning difficulty in the domain of mathematical development. So given the need for children to have a strong foundation in maths, we would, of course, as researchers, teachers, practitioners, be interested in how we might be able to measure children's math skills. And so in this paper, we talk about measurement tools as an umbrella term that encompasses both assessments and screeners. So we've defined assessments as measurement tools that are able to track children's mathematical development over time. So for example, during a longitudinal study, or it could also be in response to a specific intervention. So if you were trying to look to see whether an educational maths app had a significant improvement on children's maths outcomes, like much of my other research has done. Or you could also use these assessments to try and identify children who may be at risk or experience mathematical learning difficulties if you were to use a statistical cutoff such as those that were below the 35th percentile. In contrast, screeners are mainly for the purpose of identifying children who may be at risk or that are experiencing mathematical learning difficulties. It's not necessarily specifically for looking at change over time, either through maturation or through intervention. So again, why might we be really interested in the use of established mathematical development tools? So quite often, intervention studies may use a measure that they've developed themselves, which obviously has its advantages, but there are, of course, advantages to use an established measures which are independent of the intervention that's under study. So for example, I've contrasted two recent reviews. There's one by Vic Sims and colleagues in 2019, as well as one that we completed in 2022. And as you can see here that I've highlighted in orange, only 41% of the studies that the Sims et al. Review found used an independent or established measure of mathematical development. And in our review, we found that only 26% of studies used an established measurement tool. And like I say, this, of course, there are advantages and disadvantages to both, but there is a precedence, or kind of what's considered the sort of the highest level of evidence is to be using these independent measures. But let's just say you were a PhD student like I was many, many years ago, and you're thinking, okay, what measure should I use to evaluate my intervention? Or what measure should I use when I'm designing my longitudinal study? Or what measure should I use to try and identify children who may be at risk? well, this paper is essentially my gift to you, because what we have done is try to synthesize the range of different measures that have been evaluated for their psychometric properties for these different purposes. So that's not to say that previous reviews haven't been conducted, and I would also highly recommend these as well. So, for example, there was a review done by Julie Dockrell and colleagues in 2017, which provided the foundations for the early years measure database that was commissioned by the Education Endowment Foundation, which is a grant-making organisation here in the UK. And so given the context of the EEF, and they do their research in the UK, all of the measures that were identified for this review had to have a standardization to a UK norm, which is great if you're based in the UK, but what if you want to do maybe some cross-cultural research, or you're based in another area of the world? And so with that in mind, we hope to provide a global perspective with this review. Furthermore, this review was done in 2017. A lot has changed since then. A lot has changed since I did the first searches for this, as I will later show you. So again, there is also this need to update these reviews so that we can have the most up-to-date record of the different tools that may or may not be suitable for future research. On top of that, recently there was another similar review that has been conducted that's very similar to the one that we've done, which was done by a group of researchers in Finland, and they focused on curriculum-based measures for children's mathematical development, but they also focused, helpfully for me, they focused on an older age range. So again, their review is super helpful. It focuses on children 9 to 12 years, but like I say, our review will be focusing on 0 to 8 years old, so early childhood. So obviously identifying the measurement tools that are available are, that's a helpful thing to do in of itself. But one of the things that we wanted to achieve with this paper was to try and look at the different indicators of reliability and validity to essentially get a sense of how good are these measurement tools in terms of their sort of psychometric evidence. And so this diagram here is taken from the COSMIN protocol, where essentially they've categorized the different forms of validity and reliability. And then what we've also done is kind of added in what might be considered as acceptable thresholds for these different indicators. So to start, we've got content validity. So this is essentially, does the measurement tool reflect the target construct that it is trying to measure? So essentially, is it capturing the mathematical skills that we might expect to see for a 3 to 5 year old, for example? And this is usually assessed through agreement with experts. So you might do focus groups, you might do a survey or a pilot, or you just essentially get in a sense of whether your tool reflects the skills that you want it to. When you've then kind of designed your measure, or you've got the design of the measure, you would then start to collect some more empirical information. And when we have that empirical information, we can start tapping into other areas of reliability and validity, one of them being structural validity. So this is essentially where does the measure accurately reflect the theoretical dimensions of the construct that it's trying to develop? So, for example, if you are developing a measure that you want it to capture both number skills and arithmetic skills, you would want to do perhaps a confirmatory factor analysis to see whether there was a number factor and an arithmetic factor. And then there's a whole list of numbers there that are kind of considered as the acceptable thresholds for having strong structural validity. We've then got internal consistency. So if you've essentially, this is whether the items are interrelated. So ideally, you would want to have a high level of, you would want a high Cronbach alpha within the items that are within your measure. Further to that, if your factor analysis identified 2 factors, you would want to see that there was a high level of internal consistency within your factors as well, not just the measure overall. Then we've got reliability. So this essentially is whether the measure is consistent over time. So this is usually assessed through test-retest correlations. And ideally you would want around a 2-week interval. So you would give your child the new measure on, say, week 1, and then 2 weeks later you would get them to do it again. And ideally you'd want to see that children were getting a similar level of score within that time. And then finally, the last category is criterion validity. And essentially this is whether the measure is aligned to what we might consider a gold standard measurement tool, or it could be also external criteria. So in terms of the gold standard measures, you would commonly see things that are, you might see like concurrent correlations. So if you've designed a new maths measure, you would be like, right, we're going to test this one, but we're also going to give the children the Woodcock-Johnson or the team of 3 or another one that's considered as a gold standard. We would get, and then if you see a similar correlation between these two tests, you would say that my new measure is just as good as the team of 3 or whatever the other measure is. You would also, particularly for identifying children that may be at risk or need additional help in terms of mathematical difficulties, you would also be interested in the diagnostic accuracy of the measurement tool. So essentially whether it's sensitive enough and specific enough to identify those that do have MLD or are at risk, and also accurately identify those that aren't at risk as well. And again, there are these kind of commonly considered thresholds for these levels of evidence. So with all of this in mind, the aims of our review was we wanted to provide an overview of the measurement tools. So these are assessments and screeners, as I described earlier, that have been evaluated for their psychometric properties for measuring children's math skills in early childhood. And we've defined early childhood as 0 to 8 years, which is based on a UNESCO. There's a lot of disagreement, but we went for 0 to 8, and that's the definition that UNESCO use, and it links a lot to the kind of educational systems that we have, particularly here in the UK. And then our second aim was to, once we've got this overview, we then wanted to synthesize the reliability and the validity evidence that was reported for these different measurement tools, including in relation to some of these common acceptability thresholds that I've just described. And then based on this evidence, what we really also wanted to do, again, to kind of provide this helpful tool to the research community, was to try and identify which of the measurement tools had the most promising sort of evidence-based or psychometric properties to kind of provide sort of best evidence or best guidance for future research, so that we can ensure or support the rigor of work in this field. So we have quite an extensive search strategy. So it was, first of all, we pre-registered the protocol on the Open Science Framework. This was a project that I have done unfunded, that I started, I don't care to admit how long ago. It's gone on for a while, but it's been worth it. But we conducted the original search back in March 2021. And so we searched a range of different academic databases, which are listed here, as you can see, with this search string. And we also did a grey literature search of preprints and the Open Science Framework as well. But because it took so long to do it all and collect all the data, and when I finally got to the point where I was able to write the paper up for publication, a couple of years had passed and it felt out of date. And so we ran an update. We repeated the search back in summer last year. So we ran the search again, going from January 2021 to what would have been June 2023. And that also, at these 2 phases, it also included a backward citation search. So we looked at the reference list of all the included papers that we found. But then, as of Monday, I have also conducted, as we've submitted it for publication, we've had some really, really helpful reviews. And as a consequence of that, I've also now done a forward citation search of all the included studies since then. So it feels a bit messy. It was quite messy, but you'll see in the Prisma diagram later on, it does look quite neat. So we've made sense of the chaos, shall we say. So once we ran the search strategy, we were interested in we were including studies based on a range of inclusion and exclusion criteria. So first of all, the included studies needed to report on the psychometric properties of the measurement tool. The measurement tool could be any area of mathematics, so it could be arithmetic, number, geometry, shape, space measure, whatever kind, as long as it fell into the bracket of maths, that was fine. However, if it spilled over into maths anxiety, maths language, maths vocabulary, that was unfortunately beyond the scope. We were also needed to exclude papers that were asking parents or teachers their perceptions on the importance of maths. So if the question, we had some assessments that were teacher completed, so it'd be like, can the child count to 5? That would be included. But if it was, I think counting is important, that would be excluded. I also want to emphasize that we were looking for studies that were reporting on the psychometric properties. So it was the reliability or the validity evidence that I've highlighted before. It wasn't if a study had used this measurement tool in their longitudinal study or in their intervention study. Unfortunately, that may have opened the world up to a whole other set of tools, but we had to try and keep it as condensed as possible. And that was one of the ways that we did it. Given our focus on early childhood, we wanted the tools to focus on children that were aged 0 to 8 years. However, if, for example, the tool was suitable for a wider age range, so if it was suitable for 5 to 11, it was still included because it fell within that 0 to 8 bracket. No restriction was placed on the measurement purpose, so whether it was an assessment or whether it was a screener, because obviously that was something that we were interested in. Nor did we place any restriction on the type of assessment. So quite often, I'm kind of giving a spoiler away now, but a lot of the measures are child direct measures, but sometimes that's not practical or not possible in the kind of study that you're trying to design. And so we were also keen to capture other forms of assessment, whether that be through observation, whether it be parent or teacher reports, to try and give this kind of holistic overview of the options available. We also wanted to take a global perspective with our review. So we were also inclusive of any tools that had been developed in other countries, but given our own language capabilities, they had to be, at least the full text had to be available in English. So there was a couple of papers where it was the academic article was written in English, but the maths test was, say, in French. So that would still be eligible because we ourselves could extract the information that we needed. There were a few papers through the search strategy that we found that were evaluating the properties or the sort of the suitability of large-scale tests, such as those from PISA or those that are used particularly in the states, or like specific states. So, like for example, like a statutory test in Texas, for example. But again, given the sort of broad scope that we'd already got, we restricted those out of the inclusion and exclusion criteria. So with all of that in mind, this is the Prisma diagram. It is very small, so I have highlighted all the relevant information that you need in this orange box here. So in short, or in total, across both search strategies, we found 15,000 records through the search strategy. Just over, or nearly all of them were screened at title and abstract level. Just over 500 were screened at full text, and this resulted in a final total of 71 studies, which captured 58 measurement tools. So, as I also mentioned, we did a forward citation search, or I did a forward citation search on Monday. So, unfortunately, that information is very hot off the press, and I haven't been able to integrate it into the results as of yet. So everything that I'm going to talk about now is a reflection of the 71 studies and 58 measurement tools. But what I wanted to highlight in this graph here is just to show you the steep increase in the number of published studies that have evaluated measurement tools in the last sort of just over 20 years. Quite a lot, and particularly, or it's great on one hand for us because we're developing the evidence of the tools that we're using. Less so for me because it's made the review a little bit challenging. But I do think it's good news, and it's great to see that people are validating, like I say, the tools that they're trying to use in their studies. because obviously then that can benefit all of us as well. So with that in mind, like I say, it was 58 measurement tools, 37 of which were classified as assessments and 21 were classified as screeners. And here are all of them. This is just to show, this is the 58, yes. The ones that are highlighted in green are screeners, the ones in black are the assessments. I shan't dwell on it too much, but it's just to demonstrate that there's a lot out there. But obviously when we start to sort of break it down into different purposes and quality of evidence, it does get a lot slimmer. Okay. So
Sorry, I was speeding through that.
no, it's okay. Or we can pause and reflect.
I had a question, Laura.
Yes.
Actually. So you had 71 studies, but 58 measurement
Yes.
tools. So that
Yes.
means some of the measurement tools
Yes.
have multiple evaluations.
Yes, absolutely, yeah.
Are any of those indicated on there? Which ones are the more popular, or?
No, I haven't looked at what's the break, or it is
Yeah.
included in the final paper. There is like the table, and it will have the name of the name of the assessment, and then in brackets all of the papers that are associated with it. But I haven't got it here as to say how many are there per one. For the most part, the majority of them were only like, there was only one study. There was a few that had sort of like 3, 4, sometimes even more. So
Interesting.
yeah.
Thank you.
That's fine. Okay, so just as a quick overview, the majority of the, as we might expect, the majority of the tools were child direct and were administered on a one-to-one basis, quite often with a trained assessor in a paper-based format, which again is, if that's what you're able to do and you've got the sort of the resources and capabilities to be able to do that, that's great. But of course, there may be situations, for example, if you're doing a large scale longitudinal study and you've not got the resources to be able to do one-to-one assessments with every child, what you might want to do is see if you could integrate some of the maybe parent report measures as part of a questionnaire, for example. And that could, it might not be as good or perfect, shall we say, but it still might give you some indication of children's mathematical skills within the kind of sort of time, cost, benefit that you have to just naturally decide on when you're developing your research studies. In terms of the area of mathematical development, what we've done is for all of the included measures, we've pulled out how the authors have described their tests. And then based on that description, we've categorized into whether they tap into number skills, arithmetic skills, or more shape, space, and measure. Again, whether you might expect it, I'm not sure, but the majority do tap into number and arithmetic, and less than half tap into this kind of like broader conceptualization of mathematical development. Also, interestingly, well, again, as you might expect, the majority of the study, or the majority of the tools, were developed in minority countries. So by that, it's where the minority of the world lives. So essentially, it's places like America, the UK, Europe, and of course, the majority of them were also developed in English. We found that 9 of the assessments and 3 of the screeners were evaluated in different countries, cultures, and language groups, which is helpful, but it obviously can then maybe limit the capabilities to do maybe cross-cultural research, because you know how people might use or talk about maths, or how math is presented, or like numbers are presented. So for example, English and French, you know, in English you'd say 99, and then I'm going to embarrass myself because I don't know. I know it's sort of like 2 and 40 or something. It's a lot more complicated. And so, yeah, how you would need to consider some of those factors into the mathematical test, because you wouldn't want one group to be necessarily have an advantage over another group that's kind of as a result of the test and not necessarily their skill level. But there is promising news in that there is progress being made in that space. So that's in terms of the overview, so our kind of first aim. The second aim, in terms of trying to synthesize the psychometric evidence of these tools. What we've done is for all of the, we've extracted all the information in the different areas of the Cosmin taxonomy that I mentioned earlier. So we've got content validity, criterion validity, internal consistency, reliability, and structural validity. So here, these along the bottom. And we've extracted all that information, and then we've been able to reference that in relation to the acceptability thresholds that I mentioned at the start. And as you can see in this table here, there are six mathematical assessments that meet more than two or more of these acceptability criteria.
Well, there are only 1, 2, 3, 4. There's only those 6.
So sometimes they've been measured. So like that they might have assessed, say, for example, criterion validity. However, it may have just fallen short of the threshold, so it would be categorized as mixed or low.
Right.
It may not have reached the threshold that we were looking for.
Why do so few bother with content validity?
They might, they don't necessarily report it.
Yeah.
Yeah. And then this is what it looks like for screeners. So we've got 4 screeners. And yeah, similar levels where, you know, content validity is not as, or it might be assessed, but it's not necessarily reported. But what is helpful is that the criterion validity here is positive for these ones. So that would be whether it is related to an external measure or whether it's able to be diagnostically accurate or predictively valid of later difficulties. But again, if we tie this into the kind of sort of global aim of the review and some of the findings I mentioned earlier in terms of what's available and where, although there is, you know, there are 10 measurement tools that show this kind of promising level of evidence, actually still the majority of these are in English-speaking countries. So the ones that are in the black boxes are English-speaking, and the orange ones are where it's available in multiple languages. So DIFA is in Hungarian, Stella. The ENT is in a range of different European languages. The numeracy sense screener is in Turkish and in English. And then the ELOM is in South Africa, a range of different South African languages, dialects, and English as well.
Can I just correct you?
Yes.
I'm one of the authors. We actually did validity and reliability both in Australia and in England.
Oh, yeah, but it's still English speaking.
Huh?
But that's still English speaking.
Oh, it's only English speaking. Okay,
Yeah.
It wasn't just in Australia.
Yeah. No, of course. But it was, yeah, no, I get you. Yeah. And it is listed, I think it's listed as both there. So then we've got another key finding. So we were saying that so we found it, was it 11 screeners? I've lost track. 11 of the 11 screeners, only 4 of them. So they're the 4 that are listed here, I think.
MLD.
That tapped into whether they're able to accurately identify mathematical learning difficulties or children that are in need of additional support. So we've got the ASPINs, the MESI, and the SIMP test were able to either accurately diagnose or were able to distinguish between children with MLD and typically developing children. And then we've got the number sense screener, which had acceptable levels of predictive validity. So whether if a child did poorly on the numeracy screener at, say, age 4, did it then predict low performance on a different maths test at, say, age 5 or age 6? And then there's an ongoing question of what is a gold standard measure in early maths? So 8 of the assessments and 1 of the screeners were concurrently aligned with another measure of mathematical abilities. And the most common or widely used external measures for this purpose were the TEMA, as well as the Woodcock-Johnson 3rd edition math subtests, which is helpful to know. And I've been able to extract the information from the TEMA because I have a copy of the TEMA. The Woodcock-Johnson one I don't. So if anyone does have a copy,
Thank you. And we'll talk to